Hi guys, just thought before I do the video today, I'd just talk to you a little bit about this thing that I've just got for my Microbit. It's a little breakout connector. I got it off eBay for about £7, came in a couple of days in the post. Basically, the idea is we plug the Microbit in up here and we have access to all of these little pins that we normally wouldn't have access to by using some breakout cables. I don't know if I need a breakout ribbon for it or anything like that. I do have one for a Raspberry Pi that I think might be suitable. But basically you just slot your Microbit in like that. Just show you that again. So you're just slotting it in. And we've also got a little battery connector here. So I'll get the battery connected up to that and you'll be able to see that in fact we have full power to the Microbit just using those little things and start playing around with that. So next couple of videos, maybe after I finish this game tutorial, we might have a look at doing some breakout with some LEDs or something. I'm not really a hardware guy, so I don't know how successful that's going to be, but yeah, might play with some hardware in the next couple of videos. Welcome to episode 5 of our trail finding game in Python for the Microbit. Today we're going to be fixing our bug from last week, finding out what went wrong, and then moving on to try and actually create our win-loss condition and maybe create a score, maybe even save a high score, something like that. But for now, let's have a look at this. Well, what's this? I've got this new editor, Mu. And what is Mu? Well, Mu is an alternative to using the inbuilt, the online editor that you have for the Microbit. Instead of having to download a hex file and drag it across, I now have this lovely flash option, which will let me flash our code from last week directly over to the Microbit. Once that has run, we will be able to have a look at it. We're going to have a look at this code, and we're going to try and work out what went wrong last week. So, well, what's happened? So, when I reset it, I'm going to have a look and we have a new trail. When I press the down button, we generate a new trail again because I've gone off piste, but it's generated it in a new spot and then I get a bit of an error coming up. So we're going to have a think and see what's going on here. Well, how's that happened? Why has that moved? Well, let's have a look at this bit of code here. Basically, when we set our player's position, we are setting it equal to the value of trail 0. Well, what's trail 0? Well, trail 0 is this, our first element in our trail array. Now, that means that we're getting a new version of this, are we? Or are we not getting a new version? Well, let's find out what's going on. So we've got, say this was the trail. And here, instead of going right, once the user has started, instead of following the trail that we've just drawn, they don't go right, they go down. We reset, and then the starting point of the new trail isn't here, it's here. So we physically moved this starting point. And the way we've done that is with our memory management. So a few lessons ago, we talked a little bit about memory management, how it worked, and how a computer actually dealt with memory. So let's create our trail. Sorry about my terrible handwriting. Okay, let's take our trail 0 element as we have done before. Okay, when I set this up, what this is basically pointing to is, well, an array. Trail 0 is an array. We remember that an array is just a construct like this. Okay, just a bit in memory. And we're going to set the 0th element of this array is going to be pointing to a value of 0. And our first element in the array is going to also be pointing to a value of 0. How do we know this? Well, we can see here is our list, sorry, not an array in Python, our list, and the value of that is 0, 0. So this is correct. Trail 0 is pointing to an array object of which the 0th element is 0 and the first element is 0. Now what are we doing when we say player_pos equals trail 0? Well, we create a player, let's just call it PLY for now, to save me having to write all that out. Create a player variable. We don't point it here, we point it to the object that trail 0 points to, which is there. Now, what about when we press our buttons? Well, when button B is pressed, player_pos0 has 1 added to it. Well, player pos is pointing to this. The 0th element is that, and we're adding 1 to it. So, what are we doing? Well, we get rid of that, and we put a 1 there instead. But notice that trail 0 is still pointing to the same object. What we haven't done is we haven't deleted this pointer and created a new array for this, a new list for this to point to with a value of 1, 0. We've changed the values in our existing list, which means we've changed those values as trail 0 sees them as well. So what we're going to have to do is, instead of getting this player to point to trail 0, we're going to have to take a snapshot of this at the state that it's currently in. We're going to copy it over to here, and that is what we're going to point player to. Well, how are we going to do that? Let's have a look. It's much simpler than you'd think. So all I'm going to do is, here I'm pointing to the existing value, right? I've got a pointer like that to the existing value. What we want is we want to point to a copy. The way I'm going to take a copy of a list is I'm just going to pass it in to this function called list. And what that's going to do is that's just going to allow us to point to the right place. And let's not forget that here we also need to do the same thing when we reinitialize the game. Okay? Let's get that code running and let's see if we fixed our bug. Okay. So, let's press our reset button, and there's a new trail. Let's press the right button, gone off the trail, it's generated a new one. Start point was in the right place still. Let's press down now. It's going to generate a new trail. If we go down, yep, that's all good, we're following the trail. If I press down again, we're off the trail, and there we go. It's always generating our points back at that start point, so we have successfully managed to fix that bug. Well, now that we've done that, where are we going to go to next? Well, let's say if I go all the way through my trail at the minute, I can finish it, I can get to the end, but we have no way of testing that we've reached the end. I can just keep going and going and going, so there's nothing to stop me once I've got all the way over here to the far side. Let me just get my pen sorted out. So once I've gone from here, okay, I'm going right. So let's say it's a simple trail, right? And we go all the way across and all the way down. That's what the trail is. Okay, so we start here, then we go here, then we go here, then we go here, then we go here. We go down, we go down, we go down, we go down. And that's our win condition, we're here. But the code doesn't stop running. I can go down or here again, but of course this isn't part of the trail. And in fact, because our trail isn't even long enough to hold anything past here, if I do that, I'm going to get an index out of bound exceptions, because I'm going to be trying to look at this element here. And of course that element doesn't exist, we don't have it. We don't have anything after this 0.44, so I need to check as we're going if our player position is equal to the value of the last value in our trail list. Well, how are we going to do that? Quite simply, in fact. All we're going to do is I'm going to say, let's create a new variable to hold the score of the player. Okay? And we're going to say that score is equal to 0. And we're going to make that a global. And the reason we're going to make that a global is, oh no, we're not going to do that yet, we'll do that later. Basically, we're going to need a way of we're going to need a way of setting this score back to 0. What we'll do is we'll actually just do that inside of our main loop instead of writing it into this initialize function. So our score when we start is 0. Is that correct? Yes, of course. Once we started, we can't have a score that's anything other than 0. So what am I going to need to do now? Well, inside my main loop, we need to check whether the current position of our player is equal to the final position in the trail, which is always going to be 4, but we're not going to write that in. Remember here, we're pointing to just the first location. We're just pointing to this. We're not directly saying that this is going to be equal to 0, 0, because if we did that, it means that this code can't be used for anything else. It's very specific to what we can do with it. So I'm going to say now, if the player position is equal to this value here, the last position in the list, then let's add 1 to the score, and then we're going to generate a new trail. So let's say if player position is equal to trail, and the location in trail we want is the length of trail minus 1. Why do we want length of trail minus 1? Well, let's have a look. Trail is 1, 2, 3, 4, 5, 6, 7, 8, 9 long. But this is our 0th element. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So this here is our 8th element, right? Meaning when I call the length of trail, when I say len of trail, what that means is how many objects are there? Well, there's 9 objects, but we're only going to look at the 8th object. So the length of trail minus 1. So if the current position of our player is equal to the final position in the trail, add 1 to the score. Score plus equals 1. Show the score. Display dot scroll score. And then we're going to initialize. Reset the program and generate a new level. Okay, and I think that should be just about everything, except here we have our die condition, and what I want the die condition to do is reset the value of score back to 0. Okay, that's it, and we're going to put that code instead of there. We're going to put it there. Okay, I think that should work. I think that should be everything we need to do. Now it's down to me to actually correctly remember where any of these trails are. So let's flash this over to the Microbit. I'm going to record it, and basically the only way we can check this works is if I actually remember where a trail was. So let's have a look. So down, across to there. So we're going to go down first, across, down, across, and down twice. And we've printed score because I'm stupid. So instead of printing the string score, we need to print score plus the string value of the score. Okay, let's flash that back over. Let's have another go, and it's down to me to remember what this trail actually was again now. So let's get filming the Microbit. Okay, quite a simple one again. So all the way across, down 1, across, and down. And our score is 1. And something went wrong there. Why haven't we shown the trail to ourselves? The reason we haven't shown the trail to ourselves is because here we're supposed to set playing equal to false. Otherwise, we don't come back into this function to generate a new trail, print a trail. Okay, so because we haven't generated a new trail, we can't look at what the next trail is going to be. It's not generated one, it's not shown as one, so we can't do anything. So let's say set playing equal to false in order to generate and show a new trail. Okay, and we're just going to say playing equals false. Let's flash that over and let's have another go. And this requires me once again to have to remember a trail. So this game's harder than you'd think, surprisingly. So there we go. New trail has come up and I have no idea what it was. I did not take the time to remember. Okay, there we are. So down, down, down. Cross to there, was it? Down. And then was it down again? Yes, there we are. So the score is 1. Generating shows a new trail. Down, down, across, 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 down, down, and now our score is 2. Okay, got a new trail. Let's just check that our value of score resets. So I'm going to kill myself, get a new trail. I'm going to try and follow that one correctly now. And if our value of score is 1, we're correct in our code. If our value is 3, then we're not. And there we are. So it's reset our score back down when we did die. So I'd basically actually be tempted to call it quits there, guys. We've generated an entire game. As far as I'm concerned, we don't have any menu options. We don't have any instructions, any of that stuff. But we've got a game that can count up in score, reset back down. The only thing that we might do is, I think next session, we're just going to look at storing information on the Microbit's file system. And to do that, we will need to use something called files. We're going to actually create a text file to store our the current high score. And what we'll do is we'll display the high score when the game starts, and that's something called persistent memory. Persistent memory, or non-volatile memory, is memory that isn't lost when the device's power turns off. Volatile memory, non-persistent memory, is memory that is lost when the power is going off. So we've done a pretty good job there today, guys. I'm quite happy with where we've got to. I've managed to build basically an entire game. Just going to add a high score in next time, but I hope you did enjoy today's video. Check over here, obviously, for the next video, episode 6, where we are going to have a look at getting a high score into this game. Obviously, look over here for episode 4 if you need to go back, read anything over again. Please don't be afraid to leave any comments if you haven't understood something, or if there's something you'd like me to clarify, or if you have any improvements to my code. I'm not the world's best programmer, guys. I've been coding for a good couple of years now, but I do a lot of things wrong. I have a lot of bad habits. If you've seen anything where you think, why has he done it that way, or that I shouldn't have done it that way, please do let me know. I can address that then in later videos, and maybe you guys can help me become a better programmer. So thank you very much for your time today, guys, should I say, and I'll see you in the next video.